All right, here are solutions for perfect problem 7 from Math 213. This problem is all about constructions. So I think the easiest way to do these things is to kind of prove that you have the skills to do certain constructions and just show it once, and then you can just kind of assume that you could do it over and over again if you wanted to. So the skill, really the one that you'll need to use the most, is this idea of a perpendicular bisector. So I'm going to do this kind of off to the side once, and then when I'm drawing, I'll always be able to just add perpendicular bisectors wherever I need them. So the idea with the perpendicular bisector, or really even more general than that, is if I have a line and a point on that line, I can construct a line perpendicular to my original line that goes through this point. And so the way I do that is I'll start with my compass, put the pointy end of my compass here, and measure out to find 2 points on this line that are equidistant from my original point. So I can kind of measure out and get this guy and this guy. And then from those 2 points, I can put my compass, the pointy end here, and maybe the pencil end over here, to sort of draw a circle that goes centered at this point here. Here's my best attempt at what a circle would look like if it was centered at this point here, with the radius here. And then another circle that's centered here with the radius here. So I don't know, maybe it looks something like that. And if I drew those really carefully, that would define 2 points where those circles intersected. And if I have 2 points, I can connect those 2 points with my straight edge. And so what that allows me to do is create a perpendicular bisector. So really a couple of things. If I start with these 2 points in green, the perpendicular bisector is this green line. If I start with a single point in red, I can create a perpendicular line through that point. So I can do either of those things. And so now that I have those skills, I'm going to go through and I'm going to attack this problem. Let's see, a square with area 11 would have sides with length the square root of 11. So how do I construct a line segment that's the square root of 11? Well, let's see, where? Down here maybe. Construct a line segment with length square root of 11. Well, I have 1 is given to me up here. And so if I have 1, maybe that's 1. I can do that 3 times. I can draw a line, and then I can measure out a segment of length 1, and I could do that 3 times to get a segment of length 3. And then if I have a segment of length 3, I can draw a perpendicular using this skill line segment at one of the endpoints and draw another segment of length 1. And if I connect these 2 points to create a triangle, I will have a right triangle whose side lengths are 3 and 1. And so using Pythagorean theorem, 3 squared is 9, 1 squared is 1. This must be equal to the square root of 10. And you're like, great, square root of 10, that's not what you want. You want the square root of 11. Right, but now that I have a side length of square root of 10, I can take this line and at this point draw a perpendicular. That was the skill that I proved that I had up here. So maybe this right here is 1. Didn't plan that out very well. And so what that does is it creates another poorly drawn triangle. Let's try that again. Let's connect this point and this point. And maybe we'll say that that's length 1 right there. So I have 1 in the square root of 10. So to figure out this length here, well, square root of 10 squared is 10. 1 squared is 1. 10 plus 1 is 11. So this length is the square root of 11. And so now that I have a line segment with square root of 11, I can construct a square by copying this length, square root of 11, drawing a perpendicular here, square root of 11, drawing a perpendicular here, square root of 11, and drawing a perpendicular here and connecting the point. That'll be the square root of 11, and this will be the square that I'm looking for. Okay, what about B? B says an isosceles trapezoid with area 4 units, and B1 equal, the first base is 2 more than the second base, and both of those are, sorry, the first base is 4 more than the height. Okay, so a couple of ways you could attack this. You kind of assume that I bet he's giving me nice numbers here. I bet this works out nicely. Maybe I should guess and check. If the height was 1, for example, then that would mean this was 5 and this was 3. Wait a minute, that might work out perfectly. If h equals 1, b1 is 5, b2 is 3, and so the area is equal to 1/2 b1 plus b2 times the height, which is exactly 4. Hey, lucky guessing that if I want an isosceles trapezoid with area 4 units, it's b1 would have to be 5, b2 would have to be 3, and the height would have to be 1. So how am I going to draw that thing? Well, I can start out by using my, should I try to draw these to scale? I guess. I can draw a line, and I can measure out length 1. I can do that 5 times. And then this will be my B1. I want this to be an isosceles trapezoid, and I want B2 to be equal to 3. So if I put B2 somewhere up here, if I put B2 directly over this part of it, it'll have length 3, and it'll be isosceles because the angle here will be the same as the angle here. So how do I draw that? Well, I can draw my perpendicular line right here. And I can copy a perpendicular line with length exactly 1. And I can draw a perpendicular line here and copy one with length exactly 1. And that'll define a point up here. I can connect these 2 dots and connect these 2 dots. And then connect these 2 dots. So really the only skill that I needed was this perpendicular bisector, which I showed that I already have. This would end up being 3. This area would be equal to 4. This is part B here. And then finally, somewhere, part C, I guess this should be in blue maybe. An equilateral triangle with this area. Well, okay, so note, maybe up top here, if I have an equilateral triangle with side length x, then if I want to figure out the area of this triangle, I need to know what the height is. But I can use Pythagorean theorem. This leg here would be half of x. This would be my height, and this would be x. So I got half of x squared plus the height squared is equal to x squared. So when I multiply this out, I get 1/4 times x squared. And so if I subtract 1/4 of x squared from both sides, I get that h squared is 3/4 of x squared. In other words, h is equal to the square root of 3 divided by 2 times x. What does this tell me? Well, I can figure out the area of an equilateral triangle by taking 1/2 times the base, which in this case would be x, times the height, which in this case would be root 3 over 2 times x. And that right there is supposed to be equal to 4 root 3. So you can kind of stare at this thing and be like, all right, what number should x be if I want 1/2 times x times root 3 over 2 times x to be equal to 4 root 3? Well, if x is equal to 2, for example, these 2 would cancel out, the 2 and the 1/2, and this 2 and this would cancel out, and I'd be left with root 3. Oh, not quite big enough. I want 4 root 3. What if x was equal to 4? Well, if x is equal to 4, 4/2 is 2. That's nice. No, 4/2 is 2. Yeah, that is true, and that's nice. So I get 2 over here, but I want 4 root 3. But don't worry, you got another 4 over here. Divided by 2 gives you another 2. What I'm saying is this implies that x is equal to 4. So all that to say that if you want to draw an equilateral triangle, so equilateral triangle with length 4 will have area 4 times the square root of 3. So when I'm drawing my equilateral triangle, all I have to do is draw side lengths 4. That'll be a little bit tricky in here. Maybe you can assume that that was 1. I'm drawing a line. I have 1. So then that's 2, and that's 3, and that's 4. Let me shift this over a little bit so that when it prints, it all shows up on the page. This might not be quite to scale, but hopefully you'll be all right with that. There's 1, there's 2, there's 3, there's 4. But how do I draw an equilateral triangle? Well, the nice thing is that now I have length 4 here, so I can put the pointy end of my compass here and the drawing end here, and I can kind of create this arc, and this will signify all of the points that are exactly a distance of 4 from this point right here. So what I'm saying is my other vertex of the triangle, one will be here and one will be here. The other one has to be on this arc right here because it has to be 4 away from this guy. But it also has to be 4 away from this guy, so I can do the same thing where I put the pointy end here and the drawing end here, technical terms, and swing this arc up here. And the 2 points where these arcs intersect is the 1 point up here that is exactly 4 from this guy and 4 from this guy. So if this is 4, that's got to be 4, and that's got to be 4, and the area is equal to 4. That's not a 4. The area is equal to 4 times the square root of 3. So these are your drawings. They won't look exactly like this. Like, right, this is 3, and this is 4. It looks like your 3 is longer than your 4. Yeah, this isn't all to scale. I just crush them all in here so that everything would fit. But hopefully this gives you some idea. I'm going to write up here see video, or hear video, I guess, for explanations. Because I think just taken by itself, these solutions won't make a whole lot of sense to people. But hopefully with me talking you through all these, you can kind of follow this and do this stuff on your own. So I guess I'll end this perfect problem video here.